Okay, so I promised you at the end of last video that we would be talking about answering this question, how much salt is in the tank after a long time? So we're just going to do that real quick right here. So initially our equilibrium answer was that if x equals 600, dx dt equal to all that stuff was equal to 0, and we could show it's stable from like a phase diagram. So x heads to 600. But now we can look at that in terms of our solution too. So our solution answer is that if x equals 600 minus 550 e to the minus t over 100, then as t goes to infinity, we have e to the minus t over 100 goes to 0. And x goes to 600 minus 0, so x goes to 600. That's the same answer, but we've arrived at it in a different way. So both of them conclude after a long while. Oops, sorry about that. I don't know what I did. There we go. It's close enough. After a while, there are 600 pounds of salt. That's the answer. But the reason we did it this other way is because there's a special word for the term that goes away as time goes on in a solution to a differential equation. So note, in our solution, x equal to 600 minus 550 e to the minus t over 100, the term minus 550 e to the t over 100 drops out as t goes to infinity. This has a special name. It is a transient term, which just means it disappears as t goes on. And it sort of initially drives behavior. But then sort of the solution tends towards the critical point, or the equilibrium value. And if you've spent much time thinking about exponents, you know that it doesn't actually reach that point. It's just sort of something it gets close to. And the reason I talked about that is just because it's the sort of thing that can come up when you look at solutions, so it's good to be able to identify that type of thing. Because it's a change in topic, I'm going to end this video here, and then we'll pick up in the next video with that last thing I wanted to cover, piecewise functions.